So we know the relation, and last week we defined the relation, and we talk about some properties of the relation, and this week we will start type of relation. And a relation, as a definition of the reflexive relation, a relation R on a set A is reflexive. So what is the condition of reflexive? If a member of the set A relation A for every A is element of set A, that is, if A is the member of R for every A member A. So there is also more. R is not reflexive if there exists a member of a set A such that pair of AA is not element or member relation set R. So let's write the example. Example, let's say we have as a set A has the number like 1, 2, 3, and 4. There is relations as a R1, R2, relations on set A. R1 is equal as a pair 1, 1, 1, 2, 2, 3, and 1, 3, 4, 4, and that's it. There is R2 as a relation pairs 1, 1, 1, 2, 2, 1, 2, 2, 3, 3, and 4, 4. And R3 1, 3, 2, 1, and R4, and let's say R4 is here, the empty relation, and R5 is equal A product A, the universal relation. So determine which of the relation relations are reflexive. So what was our condition? If a relations pair A, there is a relation A to A for, each member of set A, like A, and we have to A element of R, for A is element of set A. So let's look at R1. There is the R1. And what is the inside of the R1? 1, 1, 1, 2, 2, 3, 1, 3, and 4, 4. Right? Can you hear me, dear friend? So we have, as you see, for set A, 1, 1 is here, but there is no 2, 2, 3, 3, but 4, 4 is here. So R1 is not reflexive, right? Do you agree that? If relation R on A is reflexive, here is the solution for answer. Reflexive, the four pairs, 1, 1, 1, 1, 1, 2, 2, 1, 1, 2, 2, 3, 3, and 4, 4. Four pairs contains if relation R on reflexive, the four pairs contains by R. So according to that, R1 is not reflexive, right? And R2, there is the 1, 1, and 2, 2, 3, 3, and 4, 4. R2 is the reflexive. And R5, of course, reflexive. So we can say R2 and R5 are reflexive. And what is the rest? R1, R3, R4 are not reflexive. Okay, next one, symmetric and antisymmetric relation. Symmetric and antisymmetric. Let's write the definition. A relation R, again on a set A, is symmetric if whenever A relation B, then B relation A, that is if whenever AB member of relations R, then BA element or member R. There is a reverse side also, thus R is not symmetric if there exists a B member of set A and such that AB is element R, but there is no BA in that relation. Okay? And let's see same example for symmetric and unsymmetric. Example, again we have set A, 1, 2, 3, and 4. There is the relations as a R1, 1, 1, 1, 2, 2, 3, 1, 3, 4, 4. R2, 1, 1, 1, 2, 2, 1, 2, 2, 3, 3, 4, 4, and R3, 1, 3, 2, 1, and R4, empty relation, and R5, universal set. So which are relations symmetric or unsymmetric? Okay, what do you think? Okay, what is your idea? For R1, R2, R5, symmetric. How about R1? R1 is the non-symmetric. How about now? Can you hear me? Okay, R1, there is the 1, 1 and 1, 1. This is also reflexive and also symmetric, 1, 1 inside of that relations. And 1, 2, but there is no 2, 1, right? So 1, 2, member of R1, but there is no 2, 1. So this is not symmetric. Okay, R2. Sarah, how about my voice? Can you hear my voice? Dear friend, do you hear my voice? Okay. Ryan said, yes, it is clear. I see. And I hope lecture record is good. And for R2, 1111, member of R2, 1221. So this is also working 2222, 3, and 4, 4. So R2 is symmetric, right? And R2 is symmetric. R3 is not symmetric because 1, 3, there is no 3, 1, 2, 1, there is no 1, 2. So this is not symmetric. 1, 3, R3, but there is no 3, 1, R3, and R4 is also how about R4? Okay, R4 is not symmetric. Sure, Sarah? There is no element. And R5 is symmetric because it is a universal set. And next one is a transitive relation. A relation R are on a set A is transitive. Transitive. Transitive if whenever A relation B is a pair and B relation C, then we have to have A relation C that is if whenever AB, BC member R, then AC is member R. Thus, R is not transitive if there exists A, B, C element R is a pair of relation R such that AB, BC member R, but not AC member of R. So let's write the example. We have as a set A our famous set 1, 2, 3, and 4. So there is the relation R1 as a pair 1, 3, R2, 1, 2, 1, 1, 2, 2, and 3, 3, and R3 let's say 2, 2, 3, and that's it. And R4, let's write R4, 1, 1, 1, 3, 2, 1, and 3, 4. And R5, 1, 2, 2, 3, 1, 3, 4, 4. So which are the relations are transitive? So what do you think? Bouquet said R3, R4. Okay, let's check together uh, which are, transitive or not. Okay, let's write the question. Determine which of the relations are transitive in solution. Okay, for R1, we have 1, 3, but there is no 3, 1. So we will say this is the transitive because there is no more pairs. R1 is transitive. And R2, there is 1, 1, 2, 2, and 3, 3. These are the reflexive, right? So this is also transitive. So we can say, okay, R1 is working, R2 is working, R3 is working. No, R3, let's look at R3. 1, 2, right? I have to check there is something with the 2, yes. 2, 3, and then I have to have here 1, 3. Is there any 1, 3? No, is not trans. 1, 3 is not member of element R3. And R4, R4 is, 1, 1, and this is the reflexive pair, 1, 1. It's gonna be, transitive also. 1, 3, I have 1, 3 here. And there is ending with the 3, starting here as a 3, 4. I have to have here as a 1, 4. So this is not transitive. Because we don't have 1, 4. And R5 and 1, 2 is here, 2, 3, 1, 2, 2, 3. So I have to check 1, 3. 1, 3 is here. Yeah. And 4, 4. This is working. And R5 is transitive. Any question? Okay, let's write one more example. Example again 2.5. There's again A 1, 2, 3, and 4. And relations are 1, 1, 1, 1, 2, 2, 3, and 1, 3, and 4, 4. And R2 1, 1, 1, 2, 2, 1, 2, 2, 3, 3, and 4, 4. And R3 R3 is 1, 3, and 2, 1. And R4 again empty set of relation, and R5 is universal relation set. So determine which of the relations are transitive. And solution for R1, okay, let's look at R1, 1, 1. This is the reflexive, and 1, 2. Do I have here as a 2, 3, 1, 3? So R1 is the what? R1 is transitive, right? Dear friend, R2, for R2, do you hear me? My voice is okay for you? Dear friend, okay, Bukit, Sarah, and Ryan said yes. Now we are looking to R2 is transitive or not. We have 1, 1 as a reflexive pair, so we won't check that one. 1, 2, I have 1, 2, I'm looking for with the starting pair as a 2, I have 2, 1, and I have 1, 1 also. So this is working. And is there any more 2, 2, right? And 2, 2 itself again. 1, 2, 2, 2, and 1, 2. It is working. And 3, 3, 4, 4. R2 is, did I say for R1 is a transitive? 1, 1, 1, 2. 2, 3, 1, 3, yes. So R2 is transitive. So R3, I have 1, 3, 1, 3, 2, 1. R3 is not transitive. R4 is transitive. And R5 is transitive. Any question? So there is some point we have to write. And the property of transitivity can also be expressed in terms of the composition of relations. For a relation R on A, we define R square means R to R composition relation, and more generally Rn is equal Rn minus 1 composition with the R. Then we have the following results. A relation R is transitive if and only if for every n is equal or less than 1, we have Rn Rn contains R. R is the subset of Rn. R4, because of there is no element for though I have checked, 1, 2, 2, 1, and 1, 1, something like that. I won't check that properties. Rule is saying there is the A relation B, B relation C, then I have to check A relation C. How about, R1? R1 is transitive because there is only one pair. Sarah. Okay. And we write one theorem. An example, before the example, let's do break, okay? Dear friend, this is page 3. You know, I haven't got any extra lecture from the department or planning department. I don't know who cares about that situation. I'm looking for a solution to do some extra lecture. Anyway, let's do break like 10, around 10 minutes. Then see you next